In my search for the possible error, or fault rather, in the RCA, I also replaced two of the tubes which were inside the RCA and which I suspected of provoking some problems. You know, these are the original ones. So this is the 6AX4 GT damper tube. Okay, so this is the one that was inside the RCA. And then you have the horizontal drive tube, which is this one, and this is a 6BQ6 GTB. Now, I suspected either one was the source of my problem because the high voltage was rather low. Okay, when I started the RCA up with these tubes, the ones that were inside of it, the high voltage never climbed higher than, say, 3,500 volts or something like that, so 3.5 kilovolts. So I ordered new tubes, and the new tubes are over there. Now, I'll admit I already tried them out and they are good, although they are slightly different. Now, let me show you what I mean by different. So this is the damper tube. This is the original damper tube, and this is the new one. Okay, I have to admit that the new one is not really a new one, although they do say it's new old stock, but I don't believe that. I think it is used, but a low hour tube. Okay, well, you can see the new tube is quite a bit larger than the old one. So it's quite a bit higher, but it doesn't seem to cause any trouble where size is concerned. Now, look at this. The original tube has one pin more than the replacement tube. Now, I checked already on the data sheet of the damper tube, the 6AX4, and it appears that the extra pin you see on the foot of the tube is not connected. So whether that would pose a problem or not, I don't think so. So I just went by the book or by the data sheet and I installed it. Now the same thing is visible on the driver tube, the horizontal drive tube. Okay, so if you look at the pin layout of both, they both have the same size, but they have different pin layouts. Okay, so in any case, I checked on the data sheet, the pins are not connected. So great, that means I can simply install the new tubes and be done with it. Okay, so anyway, I installed the new tubes in their respective locations, and I fired up the TV, and from an image point of view it didn't change much, but when I measured the high voltage generated by the TV, so I measured the high voltage at the anode right here, then I measured a healthy 6 kilovolts, which according to the schematic is about the voltage that is needed for this TV. Actually, the schematic says it needs about 5.8 kilovolts or 5,800 volts. And it generates closer to 6 kilovolts, which is great. Now, if we look at the schematic right here, let me show you a close-up. Okay, so you'll remember I got a more or less horizontal line, but I didn't get any vertical deflection. So logic dictates that I would look first at the vertical oscillator tube and the vertical oscillator output, or the driver, the vertical output driver, which drives the vertical deflection coils of the yoke. So I started measuring all the points you see here, and one point in particular which is of interest to us is this one right here. Now, the anode of the second triode in the 6CG7 tube should measure 440 volts positive. Now, when I measured it, and I made a note of it on this little notepad, when I measured the voltage on that tube, what I got was about 10 millivolts positive instead of 440 volts. And that's a tremendous difference. Okay, so you could actually say that the voltage here is practically zero. Okay, I measure about 10 millivolts, but that's almost tantamount to zero. Okay, so in any case, that meant that I would have to trace the circuitry back and see where I could possibly find the source of my problem. Now, you'll see that these parts here were replaced, as were these two here. So, in my opinion, chances are that these parts are still good, and that the trouble is coming from further on, or further upstream, let's say. And the next part we see in the circuitry is this, the primary of the vertical output transformer. Oh dear. Now, the very first reflex would be to say that probably the primary of the vertical output transformer is open. Frankly, I hope it isn't, but the more I think about it, the more I seem to think that it might indeed be the problem, because if the primary is open, then of course no voltage will reach the anode of this triode here, of the driver tube. Okay, but what's further upstream? Well, you see that there is a sort of a short from the primary to the secondary through a 100K resistor. Why they would do that, I don't rightly know, although I suspect it's a sort of a feedback loop, which allows a sort of an amplification of the vertical deflection signal. It could also be a kind of a filtering to cut down the ringing of this circuitry here, because as you know, any circuit that oscillates also has to contend with a certain amount of ringing. Yeah, so it's like you could compare it to a spring with a mass hung from it. If you release the mass, it will go up and down and up and down and up and down a number of times. Yeah, so the force you initially give the spring by stretching it will only release itself in an oscillation which is dampened. So after a while the oscillations get smaller and smaller and smaller and disappear. So possibly this circuit here, this part of the circuitry, filters out the oscillations, yeah, or the ringing like they call it. So maybe the cause is here. There might be a short here somewhere to ground, yeah, which would mean that this capacitor here would be bad, and it says 5 microfarad. Okay, but I'm pretty certain I replaced this one, and I'm not sure, but I need to check. But I'm pretty sure I replaced this 5.6K and this 100K here as well. Okay, so if we go downwards, so we follow the circuitry, we see it attaches here. Okay, now this is a second problem. You see that power for the vertical output is taken from this point here, and this point goes to one of the coils of the high voltage transformer, and that's not good news, because it might mean that there is a short here. Yeah, there's an open rather here in the coil, and that is really bad news, because if this is open, then we have a problem. Yes, then we do have a problem. Okay, there is of course another possibility, although I doubt that would be it, but you see there is a fuse here, a fuse of 250 milliamps. Now it's possible the fuse blew up, this fuse here, which means that there's no power going to the damper tube, which means that this part of the circuitry, which goes to the high voltage, is also interrupted, which would obviously drop the voltage which flows here and up to the primary of the vertical output transformer. Now, frankly, I do hope it's this or one of the other components, but not the high voltage transformer or the vertical output transformer, because if the trouble is either here or there, we've got a problem. Right, I connected up my multimeter to the circuit, and I used 2 points for that. So I connected up one side of the meter to pin 1 of this 6CG7 here. Okay, so in effect I connected it up to the anode of this tube. And on the other side of my multimeter, I connected up to the plus of this capacitor. So right here. Okay, so the capacitor connection is down there. Okay, so these two capacitors you see here are two 2.2 microfarad capacitors, which I put in parallel to form approximately a 5 microfarad capacitor. And the plus of the capacitor is connected right here where you see the crocodile lead. The other side, so the pin 1 of the anode, which you see here, is over there where you see the black crocodile lead attached. So if I make a close-up, so right there, that's pin 1 of that 6CG7 you see here. Okay. And okay, I switched on the multimeter, and this is what I get. Open. So infinite, in fact. So in other words, what I feared has come true. Namely that the primary of this transformer is open. So somewhere here in these coils is a break, and that's very unfortunate. But I might have expected it, of course, in the sense that I remember an image of this TV when the seller was putting it online to be sold, and he had switched it on, and it showed only one horizontal line and no vertical deflection. Now, I had hoped that it would be something small, you know, like the tube, which would be out of order, you know, broken or whatever, or some component. But, well, in the end, it does appear to be this transformer, which is in fact this. So this is the culprit. And I will need to find a replacement, I'm afraid. Now, I've looked through the service manual, but I haven't found quite yet what the windings are on this transformer. So if I need to find, let's say, a compatible transformer, I will first need to find out what the windings are on this transformer before I can even think about buying a new one. Okay, the next problem, of course, is that the transformer is held to the chassis with not with screws, but with plugs. You see one of the plugs over there, okay, and another one down here. So if I am to release this transformer to replace it, I will probably have to drill out these plugs from this side. So let's have a look. Oh yeah. Oh, although It might be screwed. Let me see. No, it is a plug. You see the plug's end here. Yeah, so this is one of the plugs. The other one is buried down there inside the chassis behind the CRT. Okay, well, then the next job is quite clear. I will need to unmount this transformer, which means I need to unmount the CRT, and I might even have to, well, maybe not. No, maybe I don't have to unmount any other part, but the CRT for sure, because I need to be able to drill in that direction, and then this little transformer. Right, I unmounted the CRT, not completely, but well, as much as I needed to. Now the problem is this: I need to mill, because I'm using a small milling head on my Dremel. I don't know if you can see it. Let's see if I can make close up. Okay, so I'm using a tiny milling head on my Dremel tool, and I intend to mill away two pop-up nails which hold down the vertical output transformer, and one of the pop-up nails ends is here, right here where I'm pointing. Okay, let me see if I can sharpen the picture a bit. So right here, okay, that's one of the pop-up rivets. Now, as usual, there's always a twist to the story. The other rivet is down here in that slit, and it's right where I'm pointing at with my pointer. So right here is the end of the other rivet. Now, of course, I could unmount this assembly, yeah, to make the necessary space so that I could drill from this side, but I think I would do more damage than good by trying to release this assembly, and so I'm going to use this slit here to drill, or to rather to cut away the end of the pop-up rivet right here. That won't be easy, but there is no alternative, yeah, because if we take a look from this side, well, you can see there are potentiometers between me and the pop rivet, so no luck there. Anyway, so I'm going to show you me milling away the first pop rivet, the easiest one, here, and then I'm going to do the other pop rivet without, well, offline, let's say, without taping it, because I'll need really both my hands, because if I move a bit too much to the left or the right, I will do a lot of damage. So I really need my concentration to mill away that rivet. Alright, here we go. Okay, I think I succeeded in drilling it out. So now let's see if I can release it. Oh, yeah, there it went. There it is. Let me show you what's left of the pop rivet. Okay, well, here it is. This is the end of the pop rivet. Okay, so the output transformer is now loose on one end, as you can tell. Now I need to grind away the other pop rivet, which is down here. These are the remnants of the pop rivets which I just finished grinding, and beneath the last pop rivet was also this tab, which was bent around a few wires. So in effect it was used to hold down a few wires to the chassis. Right, so these are loose, and now of course the transformer is loose, as you can tell for yourselves. So, and you see there are 4 wires running into it. So this is, well, just let's say a regular kind of transformer. The only thing I need to find out, of course, are the number of windings in the primary and secondary, so that I can find a replacement transformer which has the same form factor, so the same size in effect and the same shape, so that I can mount it back where this one, the original one, was mounted, down there. At least one good thing came out of having to unmount the transformer. It will allow me to clean the chassis a bit more thoroughly. Right, well, now starts the detective story, where we try to find out what type of transformer this is and where we can find a replacement one. Well, the parts list mentions a transformer vertical output, and it says a KCS 100B chassis. Okay, so let me show you. It's this one right here. Okay, transformer vertical output, KCS 100B only. And the chassis you're looking at right now is a KCS 100B chassis. Now the parts number here, or well, they say the stock number, is 102046. Now, try as I might, I can't find that number on the transformer. So if I look at the transformer, the numbers it shows are up here, 972725-1, and then the number below says 352626. But I can't see for the life of me that number we just saw on the list. So that's a bit of mystery to me. Now, it's quite possible, of course, since we know that there has been work done on the chassis, that this vertical output transformer we see here is itself already a replacement and not the original transformer. Well, that's a bit of a bummer. So anyway, I'm left with a few numbers, parts numbers, and I'll see if I can find out what sort of transformer this really is. Maybe I might get in touch with a few people and who might tell me which type of transformer this is. In any case, with the parts number alone, I won't get very far. So that's it for now, and well, maybe I'll have some more news soon